This is AP Calculus AB, Unit 6, More Derivatives. We're on Lesson 4, Applications of Implicit Differentiation. We're going to be finding the second and third derivatives today. There are many cases where you might need to find a second derivative. For example, if I have a function for position, the first derivative would give me a velocity, and the second derivative would give me acceleration. And the third derivative would give me jerk. So we need to be able to find the second derivative using implicit differentiation. The step is a little bit convoluted, but not too bad. I have an expression, an ellipse function here on the screen, 4x squared plus 9y squared equals 36. You may recall from your units on conic sections that this is an ellipse and that the coefficients on x squared and y squared are not the same. If they had been the same, they would be a circle. All right. So we're looking for the second derivative of y with respect to x. So we're being asked for d squared y dx squared, second derivative of y with respect to x. Okay. And so let's go ahead and find it here. So we're going to implicitly differentiate on x. So 4x squared, the derivative of 4x squared is 8x. The derivative of 9y squared is 18y, but y is a function of x, so we're going to multiply by the derivative of y with respect to x using the chain rule. Okay, y is a function of x, multiply by the derivative of y. The derivative of a constant is 0. Okay. All right, so let's move 8x to the other side. 18y times dy dx equals negative 8x. Divide 18y, dy dx equals negative 8x over 18y. Reduce by 2, negative 9x I'm sorry, I'm getting the wrong one in the wrong order. Reduce by 2, negative 4x over 9y. There we go. Okay, so there's our first derivative. All right, so we found the first derivative by implicitly differentiating and then solving for dy dx. Now we're going to take the derivative of dy dx. And so it's necessary for me to use the quotient rule, so let's use that here. So d squared y dx squared is the derivative of the top, and I'm going to put a negative out in front. Leave that off. The derivative of the top is 4 times the bottom, 9y, minus the top, 4x, times the derivative of the bottom, 9, chain rule, times dy dx, because y is a function of x. Don't forget that step. All over the bottom squared. 9 squared is 81, y squared. Okay. All right. Now here's the step, one step that can be a little bit confusing here. I solved for dy dx earlier, and I found that it was negative 4x over 9y. Here's the dy dx. I can substitute that right here. Okay. So let's go ahead and do that. So d squared y dx squared equals negative, and I'm going to distribute the negative in. So negative 4 times 9 is 36y. Negative negative is positive. 4 times 9 is 36x. dy dx. Well, dy dx is negative 4x over 9y. All over 81y squared. Okay? So substituting and simplifying a little bit. Now let's go ahead and take one more step of simplifying here. D squared y dx squared equals negative 36y. Okay, minus 36 times 4 is 144. Xx is x squared over 9y. all over 81y squared. Okay. Now we have a complex fraction, so the way we remedy that is we multiply by the denominator 9y, but we multiply top and bottom of the fraction by 9y. 9y, 9y. Okay, when we do that, we get this. D squared y dx squared. 9 times 36. 9 times 36 is 100. Yeah. Wait a minute. Oh, I know what I did. Okay. I'm going to back up just a little bit because the numbers are getting a little crazy and there's some reducing I can do, if you don't mind. Right here. Okay. I can factor a 9 out of the 36s and the 81. Okay. And I'm just going to do it this way here. That's 4. That's 4 times 9, and that's 9 times 9. There we go. So just factoring and canceling a 9. D squared y dx squared equals, okay, now we have negative 4y, and I'm multiplying by 9y now. So multiply top and bottom by 9y. Okay, we end up with 4 times 9, or 36, negative 36y squared, because it's y times y. 4 times 9 is 36 minus, because it's negative there, 36 x squared, and the y's cancel and the 9's cancel. Okay. Yep. All right. Over 9y times 9, 81y. Okay. And let me make sure that we've got that right here. It's really easy to make a mistake, so you got to be really careful. And then y squared times y is y cubed. There we go. All right. So now I'm going to do a little bit of reducing. 36 and 81 reduce. And actually, yeah, they reduce, but I'm going to, let's go ahead and reduce again. So I'm going to divide by 9. We get 4. And something's wrong here. 4 times 4 is 16. Well, I almost need to re-record this. But that's okay, though. You're going to see real mathematics in real time. It's like 4 times 4 is 16, not 36. There we go. All right. And now, okay. And now nothing reduces, so that's fine. All right. So what I'm going to do here is I'm going to factor out the greatest common factor out of the numerator. Because what I'm interested in is this up here. I want to see if I can use this to simplify. Okay. So I'm going to factor out 4. Negative 4. Negative 4 times 9y squared. Negative 4 times 4x squared over 81y cubed. D squared y dx squared. Okay, and now I want you to notice something here. I'm going to use blue. 4x squared plus 9y squared is defined as being equal to 36. Here's 4x squared plus 9y squared. So that is 36. Okay, and now we can write. Okay, let's go ahead and reduce. Okay, making a little bit of room here. So we have d squared y dx squared equals negative 4 times 36 over 81 y cubed. All right, now reduce by 9. So negative 4 times 4 over 9y cubed. So negative 16 over 9y cubed. 9y cubed. There we go. All right. Okay, that's the second derivative of y with respect to x. Isn't that fun? You're going to have fun with this lesson.